Hello folks, well today we've got a white CB radio, and I can only think of two white CB radios. One is the Quaser with marine receive, and this isn't that, and the other is this, the Jesan KT5005 with marine receive. The Quaser one does it better, it's a Uniden built set, and it's got a separate aerial socket for your marine receive, where this derives it from the CB area, which isn't ideal because it's not going to be tuned to the VHF frequency. So it gives you two marine receive channels. I forget what they are and it's immaterial, but we will check it. But don't expect the kind of performance that you get from a real marine radio, and of course remember it's receive only. So we've got the microphone with it, or a microphone with it. It has a 3-pin plug, the Uniden style, and the customer has sent the lead with it. He's an end user. We don't normally do end users, but those who ask nicely will get. And all I need to do is to find my crocodile clips so I can spend the afternoon shorting them out. So he mentions in his letter about capacitors, but in fact these don't suffer from capacitors to my knowledge. The Uniden one, yeah, definitely. The Quaser has the same foibles that the Uniden 100, 200, realistic 2000, 2001, audio line 340, 341 suffers from. But I'll tell you what we're going to do, because I don't know whether it's been powered up for years. I know he's had it in his loft for a bit. Just take the lids off, just in case there's anything I don't want to power up. It's quite difficult fitting anything in other than church services at this time of year. But I thought we'll give this a go. We may do it in several parts, depends what needs doing. I've got the circuit diagram but no other information. I think there's enough wire there to not have to disconnect the speaker. That could save 15 seconds. So we'll plug the test equipment into the aerial socket. So put the other glasses on. I can't actually see anything dodgy at this stage. So our receive for marines there, and the rest of it is pretty conventional. Right, power it up then. No meter lamp. First thing I'm going to do is check the public address. Testing 1, 2, testing 1, 2. We've got dirty volume control. May be able to deal with that. Oh, but where's the applicator gone? Is the next question. Yeah, well, we can't deal with that at this stage. Well, that's a bad start, isn't it? Back to CB. Right, we'll switch picture in picture on, and we're in the 3 watt scale, and it's just doing over the 3 watts. 3.1. Let's go to the other channels, and it's doing 3.1, and it's doing 3.2. These don't have low power, which is frustrating for me. It's my favourite feature, but clearly these were made later on, like 89, when we were heading towards PR 2794. Doesn't have that. And see what the current consumption is. The answer is 810 milliamps. For what it's worth on this test set, we'll see what the deviation is. Well, it says 3.5, so that's whatever it is, it's not right, because there's no way this test set's going to be out that far. We're not going to do the VCO because we don't know a way of doing it. If there was a VCO problem, I would have to concoct a way of doing it, for which the customer would have to pay. But we don't need to do that because it's working on all 40 channels. And let's have a look at the frequency. Now the test set's only been on 20 minutes, and so we'll take this with a pinch of salt. It'll give us at least we can adjust it. 2779096. So it's not far out, and I'm sure by the time the test gear's warmed up, we'd be about 102. So what we'll do, if I can find a trimming tool, where have they gone? That's there. We will get that trimmed. I've got to waggle that round. Start again. It's got a wider variation than most sets. There we go. I think that's where we're going to be with that, because by the time the test set's warmed up, it's going to be a little bit higher. 2779125, but I will recheck that. So with that in mind, I'll now set the signal generator for 2779125. We're last doing CVT. I'm not really a lover of Jesan sets, but these, I seem to remember these work better than most of the others. It doesn't sound right. No, I'll test the test gear. No, we'll plug the test gear in. Right, let's have a look at the SINAD meter and see what we've got. This is not good at all. Right, 12 dB is... Oh, no, it's better than I thought. It's better than I thought. 0.53. .46. It's not right though, if you can understand that. And 2.2. Squelch, turn to full. See where it is on the attenuator. Let's put the attenuator up on the screen. And 3, 10, 30, 100, 300, 1 millivolts. It comes in at 2.3 millivolts, or at least it comes in. And the threshold, let's drop the squelch, put the signal generator to standby. It comes in a not good enough 3.1 microvolts. I think the IF's out of alignment on this. So on transmit, if we can see the meter, it's right where it should be, in the middle of the strawberry patch. And on receive, I've got 100 microvolts on, and it needs 300 microvolts to read S9. So that's not quite right at the moment. They work. Socket, we've got a dirty extension speaker socket. PA's working, the mic's working, the speaker's working. Okay, so let's see if we can work some magic on transmit. So go back to the main meter. So I've got the circuit diagram for this, but I have covered this set before in greater detail. So all we do have is the circuit. So we can see here that our transmitter, we can when we find the transmitter. La-di-da-di-da, talk amongst yourselves. That's the marine receiver, there's the transmitter. So we've got L4 is variable, then T10. We go to these earlier stages, T9, T8. So really we're looking at starting at T8 with a tune-up. So if they're labelled, wouldn't that be nice? It's probably going to be that, isn't it? But the only one I can read is T9, and T9. So I expect this is T8. What we're not going to do is touch the one with the wax in it. But I can't see any distressed capacitors, so there we are. So although this is a cheap make, they've clearly used better quality ones than Uniden did. Here goes. So we want the centre of the peak. I'm not showing you the right meter. That's the centre of the peak. Now, it's going to be one of these with these airspace collars which have to be put in the right position. I hate it when you've got feedback when you're on an extension speaker. So what's going on here? No, that's factory as it should be. Let's look at that next one. .9 watts, and that's when hot, so it's going to be definitely doing 4 when it's cold. So I'd like it to be within 0.1 of that at the band edges. We're on channel 1 now, it's 4 watts, and on channel 40 it's 3.8 watts. Current consumption is now 902 milliamps. And now we'll do the deviation on the test set behind me. It was 3.8, so it needs to come down. It's going to be that one, isn't it? Yes, folks, it is. Okay, back to this test set. See what it says the deviation is on this one. It may be right today. It is right. It actually says the peak of 2.6, so we can let that go. 2.2 to 2.5 kilohertz. What did I say? 3.8, I think it was. Right, on the meter now. This is going to take longer to do that meter lamp than the rest of the set. What we got left? I wonder if that's, I would think that one's going to be the RF meter. think we've got a dirty preset. I can use this without the applicator for that one. Unless of course it's broken. Not quite sure why that needs to be on full, but it is. Okay, so let's look at the, that should leave us with two presets, one for the receive meter and one for squelch. So if we look at the layout here, that's going to surely be the FM detector. So we go over to receive. We've got dodgy volume control, dodgy socket on the back. It's good fun between them. Let's go over to the oscilloscope. That seems to be peak. I'm going to look at this IF1 next. Just pop the squelch down. I'm going to first of all check it with the oscilloscope. Now we'll look at it with the SINAD meter. Put quite a big signal on, so it's about 12 dB. That looks about right. I'm going to do the front end, so we'll drop the signal. These are going to be IF. Do that with the biggest signal. Okay, so we've been through that several times, and of course now it's all set up right, it's less sensitive. (12 dB) is now 0.79. 10 dB is 0.63. Hopefully 20 is improved. Yes. 1.25. And hopefully squelch is improved. Or at least in such a way we can set it up properly. So 100 microvolts on the signal generator. Show you the attenuator. And presumably this preset's going to be squelch. Up a notch. Yes, it is. So the maximum squelch is 240 microvolts. That's a huge improvement from 2.3 millivolts. So hopefully we can set the squelch so it actually works in a normal way. So set the squelch on the radio, signal generator is on standby, it's parked at 0.3 microvolts, set the squelch to threshold, switch the signal generator on. You know what, it still hasn't come in. It's 1.5 microvolts. It's not good. Have another go at setting it more carefully on the radio. Shouldn't have to do this. Very careful setting, you can get 0.9 microvolts. So there you go. But I'm putting it down as 1.5 because that's when you just turn it and it works, which is what you'd expect. Let's see if we can set the meter up. There's 100 microvolts on the signal generator. It's romping across. It's that preset there. Yeah, that's dirty as well. So there we are, S9. Okay, so we are done. I need to do the meter, so I'll take a break and do the meter, and hopefully we'll get some of those presets, some of those potentiometers sprayed as well. So I'm going to end up having to unsolder that. Pop this lid off. There's a chance we can, if we can test this today, that we can get it in the post tomorrow and we can have it back for Christmas, like it matters. So where's the bulb? Oh, correction, lamp is the right word. Oh yeah, we've got this receive thing to sort out, haven't we? So I will need to go through that. So there's another bit of work. Right, I'll be back. So you'll note at this point we're doing the meter and it's awkward to get to it, just like you'd expect. So front off, thread that through. Mind you, I can thread the wires through a bit easier. Can't get this front off all the way because it's held by the wires for the mic plug. Right, let's see where the wiring goes. So we've got one uses the earth from the meter, and the other probably goes to the volume control, to the on and off switch. Yeah, it does. Well, that's a bit bizarre, because you need to... Surely it's not doing full rail voltage of 13.8, or it's not going to last any time at all, which is probably why it's failed. If you've got one end straight to ground, yeah, that's what they've done. We're going to have to put a resistor in that. Right, so I put 150 ohms in. So we've got the kind of brightness that we want, and not going to melt the plastic, and not going to burn out. Wanted to lose 3 volts there, and so 150 ohms works out really with a 0.02 divided by 3, and as Ohm's law tells us, so we're dropping that to receive. It's a 12 volt lamp. We're going to run the set at 30.8 most of its time, aren't we? And so I want it to be really presented with no more than about 10.5 volts, which is what we've got. So I'm just able to put the extra resistor there between the negative of the meter, which is where the wire was going to, and I've just been able to put that resistor in there. I can't see any bulb shown on the circuit diagram. Oh, or unless it just says positive and negative, which is weird. Where does it go? Doesn't make sense. Okay, so now we'll put the bottom back on. Just check there's no dry joints that are obvious. It certainly hasn't played up. This is either the third or the fourth one of these I've seen, and I can't say that they've been problematic in dry joints so far. Self-tappers, I don't like self-tappers. Couldn't be bothered to thread it, so they put self-tappers in. I'm trying to push this along because I've got a carol service this evening. We can do an on-the-air test even if the bulb hadn't worked on this. Mr. Chippie's not here for a couple of days, and then he won't be here Christmas Day, I don't expect, so I wanted to get this out. I'm sure he doesn't want to see me Christmas Day. Right, so let's look at this marine receiver. So it's got 2 crystals, it says here. I'm going to need a calculator, aren't I? One of the channels in the 1 position, 48.70166, so it's going to be going in at the 455 IF, so we'll better get a calculator. Where's the pink one? Okay, we've got the black calculator, not the pink one. So, what do we have, did I say? Looks like 48.70166. So 48.70166 times 3 plus Now that's, you see, that's nowhere near marine, so it must be the other IF, 10.695. 156.8 sounds like a sensible channel, doesn't it? 156.8. So we'll dial that in on the signal generator. Now I'm doing this as a courtesy, because if this had been asked for, then there'd be an extra fee. I've got to swizzle the signal generator around, but I'm just doing this as part of a demonstration. So we need to go to 156 megs. I have to think, is it cheaper to take it to another test bench where the test gear is set for VHF? Or is it, oh, you know, I've got to balance that in my head. 156.8. The frequency is adjustable on these. So there we go, 156.8. I'll just trim that fraction. I don't think we're going to do better than that. So let's see what happens. Might help if we put some knobs back on it. I better put the mic in, or we probably won't have a receive path. Marine 1. There we are. So it's doing the moment it's doing 4.4 microvolts. Now, so I'm not here to do this, but I will do this. Marine RX A is 156.8 megs, and it is, what did I say, 4.4 microvolts. I might be able to do something, you never know. We're going to see whether it's on frequency as well in a moment. So back to the circuit. Four oh one, 402, 403. Four oh one, 402, 404. So that's 401. We'll drop the signal. So what we gain, nothing I don't think. 3.4. No, it was spot on. What we're going to do is see if it's on frequency using the second signal generator. So switch, get this plugged in. Take the tone off the signal generator. We're on the 10.695. As you can see, 10.695. Just loosely coupled. I don't know which one is the first crystal, which is the second. Well, hang on a minute. There's 403 position for a different model, so it's going to be this one, isn't it? So we've got to. Let's put the volume up so you can hear that. We've got to null that. Well, it wasn't that one, was it? Yes, it was. So that's now on frequency. So now we'll do the other channel. Just put that on one side for a moment. And the other channel is 48.58 by the looks of it. 48.58 times 3 plus 10.695 equals 156435. Does that sound right? See, that could be a 6. 48.56. Let's try that. 48.56 times 3 plus 10.695. 156375. And if we substitute that for an 8, one 48.58 times 3 plus 10.695 is 435. I don't know. I'll put it in on the signal generator as 375. Swap channels. .375, tone back on. Well, that's 375. What happens if we try 435? No, it's not 435. It's nowhere near. It's 375. Right, take the tone off, bring the second signal generator somewhere. It's now on frequency 2. There we are. You're not going to hear DX boats though, especially with that arrangement. I said the Quaser, the Ladyline Quaser, definitely does it better with it having the separate aerial socket for a marine aerial. So if I can find a applicator for a get that back, for a service or switch cleaner, we can get two things cleaned which are playing up at the moment. One's the volume control and the other is the extension speaker socket. I'll tell you what carol service I've got Christmas Eve. I've got Wilsford, so that's Scratchy Corner. Carols from Scratchy Corner, what about that? Right, I'll go and find an applicator. Oh, that was easy, I just pinched a service off Mr. Chippie's bench. I'll just plug that in and out, work it about. And then we'll just, at least it's a type which you can spray easily. I'll just take the power off for a moment because I want to waggle it around more than would be ideal for the set. Power back on. There we are, that's solid. Remember to take that back to Mr. Chippie before he notices. Right, well I don't expect it's ever done 3.9 watts before in its life. That's the reel of solder on the floor. Right, turn the signal generator off. So it's not the most sparkling squelch performance because it's the squelch is slightly insensitive to what's normal, but at least I've been able to get it so much better from, what was it, 3.1 microvolts, wasn't it, to 1.5, and with very careful manipulation you can get 0.9 out of it, so otherwise it would have been no good round Scratchy Corner, which is why we developed that particular route. So put the roof aerial on. One Anna Roger. $19 Roger. You'll be lucky. It's about 4:45 on a Wednesday. nothing happening. Okay, so there we are. The Jesan KT5005 Marine CB with its 2 marine receive channels. Oh, it just spoke then. Thank you for watching. You don't see many of these.